Hello, everyone. Thank you for inviting us to NTOP 2023. Our group and I are excited to present the following topic: exploring Suricata, an available NTOP NG integration feature. The goals of this session are to promote NTOP NG's Suricata integration feature, introduce the NTOP community to the emerging threats ET community, provide Suricata rule development training, and guidance about ET's rule feedback and submission process. You should leave with a curiosity to use ntopNG's Suricata integration feature, a familiarity with the ET community, the ability to see the intent behind Suricata rules, and finally the yearn to submit your own rules to ET for feedback. With that in mind, let's get started. Did you know that since ntopNG 3.9 and above, you have the capability to ingest Suricata flow metadata and alerts? In the screenshot that we see now, we see that Suricata alerts are appearing alongside traffic ingested in your ntopNG dashboard. In this screenshot in particular, this traffic has activities similar to Dridex and Tortle. This is powerful to have in your dashboard because it allows you to see something so you can do something against the bad guys in your environment. You may ask yourself, who is creating these rules? Well, in the slide that we saw previously, those rules were created by a group called Emerging Threats, and those rules were curated and manicured to look for specifically malware. There are other groups, such as OISF. These are the creators and maintainers of the Suricata project. And when you have the Suricata engine installed, there are some basic rules provided that align with the provided protocols that Suricata already parses. For example, Suricata does support parsing SMB, and so the rules in the initial engine will be able to detect basic SMB activity. The other brands that we see below are examples of sources of IOCs that individual researchers may use to then collect and report to the greater community. They may not be the most performant of rules, but they're still something. And these are at least rules that people can begin to consider creating larger detections for. A little bit more on emerging threats. Emerging Threats was created in 2003, and they were then acquired by Proofpoint. Despite the acquisition, they continue the same goal, which is to provide rules for paid and open source users. These users both benefit from coverage against malware, phishing, and other network detected activities. These rules are unique as they have a low FP rate, as they benefit from having tuned and tweak feedback from Proofpoint Sandbox, a little bit of the global sensor detection that is around all Suricata projects. And finally, there is a lot of community feedback given to certain rules so that these rules can improve. As of today, there are 8 full-time researchers writing about 30 rules per day and releasing them to both rule sets. Speaking about researchers, I'd like to introduce some of the people behind the emerging threats community. Myself, I'm Genina Poe. I'm one of the threat researchers at Emerging Threats. I have a background in software engineering, but I did fall in love with all things network detection. I started with spam detection at Proofpoint and started to want to get into more of what is going on with malware. In general, I like looking at malware samples, phishing, and anything related to martial arts. If you'd like to send any tips or samples to me, you can find me at Bingo Hot Dog on Keybase. I'd like to pass the mic now to Isaac.
Good morning, good afternoon, ciao. I don't know if that was the right greeting to use, but My name is Isaac Shaughnessy. I'm a threat detection engineer at Emerging Threats. I mostly work on Suricata and Snort signatures. And I've also been working on some honeypot projects to try and catch some day one traffic that's out in the wild. To my slide, I also probably should have added that I'm a dog person, but that's me.
Very awesome. Let's pass the mic now to Collin.
Here we go. Well, I added that I'm a dog person, but my name is Collin Caves. I started my career in network engineering. I've been working as an independent security researcher, as not my day job, just as a community member with ET for about 2 years. I have about 7 years of cybersecurity experience. The network engineering and understanding of networks just translated really well to writing signatures and working with IDS detections. So just a little bit about me.
All right. Well, thank you, Collin. Love to have you here in our presentation. So at this point, I'm going to get the next slide. Oops, let's go back. All right, so hopefully you are seeing a slide that has Suricata in the universe. Seems like my slide deck is a little bit off. But the idea is that you now understand that ntopNG has a Suricata integration feature. You understand where to get the rules in case you want to start adding this intelligence into your dashboard, and you understand the people behind the project. I'm going to pass the slides off now to Isaac, who will talk more about Suricata language so that you can gain more insight to the rules themselves if you see them in the dashboard.
Okay, so what is Suricata? Suricata is an open source software that or IDS that runs in 3 different run modes. The first one is Network Intrusion Detection System, or IDS mode, which collects logs, PCAPs from alerts, and doesn't take any further actions on the sensor. And the next mode is Network Intrusion Prevention, or IPS mode. And that will do the same thing as IDS mode, but it can take further actions such as block or do some other like alterations or to network flows to try and like interrupt the traffic. And the third mode is network security monitoring. Its goal is to collect as much traffic as possible. Whether or not a detection occurs, it's going to be focused on giving you like metadata and intel about traffic on your network. And the way that these 3 modes will operate to extract metadata or alerts, they will use rules which we'll go into in a little bit and kind of dive into what those look like. Traditionally, the sensor placement or where you have Suricata installed will sit at the perimeter of your network. So usually that's just on the internal side of your firewall. So you should be seeing all outbound and internal or outbound and inbound traffic. You can actually have sensors deployed in various other locations. People monitor like east-west traffic. And so you can have them deployed in like various places within your network. Generally, for emerging threats, we suggest you deploy it at your perimeter. So Suricata's development is a combined effort of OISF, or the Open Information Security Foundation, developers who work for third-party companies, who may implement Suricata in their products, and then also individuals who just help out in their free time. Suricata has an up-to-date rule set that gets updated daily thanks to a partnership with emerging threats. Like Genina mentioned, they also have a rule set which is built into Suricata or provided with a default installation, which is really good for profiling certain types of traffic on your network. Emerging Threats and OISF both have our own Discords, so feel free to reach out to us there. And so I just wanted to take a moment to mention some similar detection tools to Suricata, just if it helps like frame what the goal of Suricata is. The one that most people are probably familiar with is Snort, which is another network-based IDS. It was created by SourceFire, which is now managed by Cisco Talos Labs. They offer a community edition and a Snort subscriber edition, which is basically a free versus paid tier. Emerging Threats, we maintain a Snort 2.9 rule set and hope to in the near future provide a Snort 3 rule set. Yara, this is a file-based detection tool. It stands for yet another ridiculous acronym. It's maintained by VirusTotal, and it's used for detecting files, hunting, and malware classification. ClamAV is kind of similar to Yara. It's maintained by Cisco. It's another rule-based antivirus engine, which can be used for just scanning files like a one-off, or it can run as like a daemon on any operating system and work as a standard AV. So how do we create rules? There's a basic rule development lifecycle that really can summarize the process. And the first one is hunting. The first thing you need to start a signature is something you want to catch. So whether you're finding network traffic, from your firewall or something, or from a third party or Twitter or something, you can use this to start a signature and try to like pivot off of that. The next step is writing signatures, which is what you're going to use to match this traffic and fine tune your detection to make sure that this is doesn't go unnoticed on your network. The third step is performance testing, and this is really what sets emerging threats apart, especially with our open rule set. We have a really robust QA process that every signature goes through every day, and before anything gets released to the public, we make sure it's not going to overload someone's sensor or appliance, and other rules or rule providers may not like do as in-depth performance testing. And the final part of the rule development lifecycle is feedback from the community. So whether that's from users or internal, like from our internal sandbox, this is what we'll use to really go through the rule development lifecycle like multiple times and just make sure that everything is all these rules are in a really high quality state. So the what I'm actually going to do is just pass this back over to Genina for a sec, and she'll continue on these slides.
Got it? All right. So What is the first stage? The first stage is hunting. Let's go over with a real-life example. In about a year or two ago, there was big news about cameras being exposed to the internet. When that type of information comes out, that's like juicy for emerging threats because we're thinking like, all right, so this is coming out. What type of traffic is available for us to write some type of signature on? And if there is no traffic available, is there any way that we can look into the documentation of this product, understand the typical traffic that these cameras might emit, and then understand what type of CVE that is being proclaimed as new? In that time that this camera became exposed, our team did create about 6 or more detections specifically just for typical behavior of the camera, and then about the CV itself, which is very powerful because a lot of people benefited from this detection. With that in mind, let's talk about writing rules. When you write rules, it's ideal that you start with a few tools on your local computer. You want that traffic or PCAP. You can generate it yourself, or you can get it from a friend online. Hopefully you trust that friend. You want a Wireshark appliance so that you can look at that PCAP. You would like a text editor at least so that you can begin creating notes on this rule and also creating your Suricata rule itself. We personally like Sublime because there's a syntax add-on that allows us to, pre-check our rule before we start submitting it to our testing engines. Ideally, you'd like Suricata to be on your local computer, and then you'd want to use something called SecureWorks Dalton, which allows you to test with the PCAP and the signature and various Suricata engines to see if the rule worked. We'll go more into Dalton in a bit. Let's dive into understanding what Suricata rules look like. We're looking at a malware rule. It's kind of a lot, I understand, but as we go through this slide, we're going to start understanding what exactly is here and how, if you ever saw this in your ntopNG dashboard, how you could easily break it down so you can understand what's going on. Is it possibly an FP? Or is it a true positive, TP? As we break this rule down, there are 3 areas that you want to consider. Number 1, the rule action. This is very simple. Usually it's alert. If you look into the Suricata documentation itself, there's actually more than just alert. You can do something called pass, drop, reject. But typically you only see alerts in from our rule set. The next part is called the rule header. This tells you what protocol that Suricata should be parsing, and then the direction of the traffic. In this particular example, we know that HTTP traffic is being parsed. The traffic is going to be from client to external. Any port is going to be used, and the variables home net and external net are defined in the config. It's up to you to understand if there's anything extra in this config based on what your team decided to add. Finally, we're looking into the rule options. The rule options are the meat of this SIG. So from human-friendly eyes, you probably will be drawn to the message, and that's a good idea. This gives you an idea of what the rule writer was aiming to write, their intent, but the true purest intent of this rule is in the reference. So if you ever see a rule and you're a little bit thrown off by what's happening, go check out the reference and then see if the rule writer was able to apply their Suricata rule language understanding to capture that intent. So now let's talk about the other parts of this rule section. We see that the flow is established to a server. You might be wondering, well, we already have that information in the rule header. Having this flow helps us have a bit of a performance bump because we're saying that we're only looking at established connections. The HTTP URI and HTTP user agent sticky buffers are a way for you to direct Suricata to look at these specific buffers in the traffic. And in this case particular, it's looking for any URI that has baby PHP and ends with BB. The user agent is also examined, and it's looking for this particular short string. And finally, it's also saying that the user agent should have something with the word beagle and that particular pattern in it. All right. Hopefully you've taken this rule in. We're going to move on to the next slide. So I mentioned something a bit before, and I'd like to mention it again, sticky buffers. Honestly, when you start writing Suricata rules, this is the main thing you might want to think about. It's the main keyword you might be seeing around in the forums. Just think of it as a key value pair, where the value has the extra content and quotes around it. When you look at the Suricata documentation itself, you will constantly find Suricata improving its ability to parse out the traffic and provide particular sticky buffers to enhance the performance of Suricata parsing this traffic. In this slide, we're looking at the examples of what's in the HTTP method. We can define it as get. In the URI, we can say that we're looking only for this type of malware string. And again, in the user agent, we're looking for a particular PowerShell. This is the bread and butter of Suricata. And if I had to leave you with anything, this is where you get started. Just start looking at traffic and try understanding like what possible sticky buffers might exist in Suricata. But suppose you don't really want to write rules. Let's go with what's more tangible for people looking for references. Stick to looking at the metadata of the rule, the stuff at the bottom next to the references. Again, this is where the purest intent of the rule exists. Ideally, the rule writer was able to provide public references to the intent of the rule. All of the other things that you might see in the rule, if you want to dig into it, please go check out our discourse. We are constantly trying to create a modern space for the community to talk about what does this tag mean, how could it better enhance explainability in a dashboard, if we could change it to something else, and if we are actually changing it and there might be any support between engines or rule sets. And if you wanted to make suggestions, this is a great place for you to stop by and talk to us. At this time, I'd like to invite the audience to witness a collaborative effort between Collin and I in creating a rule. I wanted to just re-emphasize with this exercise that although you may not totally get Suricata as a rule language right now, as long as you think like a rule writer, you will be able to start creating rules in whatever language set you want to create. What we're looking at right now is very recent traffic from malware called Darkgate. It typically has some malware and phishing activity, and this was one of the recent post requests that I was asked to look at. When you look at this type of traffic, but for me, I prefer thinking about what part of this request is very unique, what part of it is quite static, and that could lead to a very easy way to create a rule that attributes to this malware and also is static enough that it won't really bog down the sensors that users decide to use this rule. So just looking at this, the post request itself at around 0.1, the very sparse URI at 2, I would use that. I would also consider using the HTTP request information, in particular the keys. If you look at 0.10, 12, and 14, ID, data, and ACK, we see that there's an exfiltration here. So in a way, I'm telling myself that I think Darkgate malware has typical post exfiltration activity that's looking for an ID, data, and ACK. And this is actually quite true. If we look at other references to this malware, we see that this 123 implies certain settings that the malware has detected on the system that it is infected. I'd like to open the floor to Collin. Collin, what are your thoughts on adding point 1, the HTTP1 protocol, or the user agent to this rule?
Yeah, so if there's plenty of examples that this malware always uses HTTP version 1.0, I think it's always a good idea with enough examples to include that into a signature. In terms of the user agent, I think this comes with experience and seeing a lot of different user agents, but this to me stands out as unique, especially to this malware, and would also be another good point to write a signature against.
Okay. Do you have any other thoughts about other parts of this traffic that you'd like to highlight?
The host could potentially be unique, but those are kind of hard to write signatures against. Sometimes they can float. And then the point 11, you might be able to do, regular expression against if it's always a static, the same amount of characters. It's always, capital, lowercase letters.
Mm-hmm. Hey, that's very fair. And to that, I would say that writing rules is a very creative process. So the rules that Colin mentioned, actually that does lead on to idea like we could create a DNS signature specifically on the zocal.com as an IOC. So infected hosts could replay the rules and see if like within a period of time this DNS sig appeared. The idea of using a regular expression on the ID is actually quite interesting because if you look at the references about this malware, that ID does have a particular pattern. However, if we're sticking to a very quick rule that's going to identify this malware, we might want to save that as a different rule, opposed to the rule that I was creating, which was kind of trying to do like a quick static check of what does it even appear. But either way, thank you for your feedback, Colin. I would say that this type of conversation is very common in ET and even in the forums. This is a conversation that you could have in the discourse or online about, hey, I see this traffic, what can we do? With that in mind, I'm going to show off the rule that was created from this. I'd like to thank one of our ET members, Tony. He was the one that got the rule out first. He was able to kind of take in a lot of what we just discussed and translate it to a very efficient Suricata rule. If we're breaking it down, we see there's an alert. It's in HTTP traffic. The client is going to do a GET request. In particular, we see that he's using the HTTP start keyword to capture the entire post, URI, and protocol. And that's actually quite nifty. I've never seen that before. He also then did similar things to what Colin was thinking about, like, hey, let's just create a signature on the user agent. It did seem like, based on the PCAPs Tony was able to look at, that it was fair to write a rule on this. It wasn't going to FN or FP. And it was pretty cool that you did use the keys as part of the signature by looking into the HTTP request sticky buffer itself. And finally, a bunch of references to help others replicate the signature if they wanted to. And at this time, I'm going to pass the mic to Colin, who will talk a bit more about performance testing.
Oh, so let me take control here. So earlier, a tool called Dalton was mentioned. So in terms of a community member, I don't have access to performance tests with internal ET tools, but I can get a tool 90% of the way for them to do very little legwork to get the rule out into a community rule set. I'm having trouble changing slides. Did it change, Genina?
Oh yeah, it changed.
Okay. So Dalton, I've actually given a presentation on this before. It's a super cool tool, completely free. It was made open source by Dell SecureWorks out on their GitHub. But it's just an easy way to take PCAP data from your network that you've captured or that you found malware samples online and run it against up-to-date IDS sensors of your choice, Snort, Suricata, and even you can get output from Zeek. I think I mentioned that here. Yeah, so Dalton, why use it? It's simple, it's responsive. You can host it yourself through a Docker. It is a bit of a beast to stand up. It takes about 30 minutes, but once it's stood up, it's super reliable. Once again, made open source by Dell, SecureWorks. They have open forums. If you have issues, go make pull requests, do whatever you need. They're very open to the community adding to it. And it supports all modern and old versions of Snort, Zeek, Suricata. Why is it called Dalton? I always talk about this. I think it's funny. It's because it's the main character. It's the name of the main character, Patrick Swayze's character in the movie Roadhouse, which I finally just watched like last weekend. Pretty good 80s action movie. And while talking about this, I think Genina has been getting the demo ready. We're going to kind of show off Dalton here.
Yeah, so speaking about action, we're going to provide some action in the presentation by showing off Dalton. I'm going to share my screen. And in particular, I'm going to share. All right, so hopefully you are looking at my desktop and we're looking at my browser. Is that correct, Collin?
Yep, yeah, I see it.
All right. Right now we're looking at a Dalton internal setup at ET. I have a PCAP here. It's from AnyRun. It's from a researcher who did look at the sample, detonate it, make it do all its things. In particular, I'm going to see if our check enroll works. I'm also going to look at Suricata 5 itself. So after we add the PCAP, select the sensor, use a custom rule as input, as opposed to the defined rule set. Usually with a Dalton install, you will have the open rule set readily available so that you can test against your PCAP against our open rule set. Again, this demo, we're just going to use this one rule. All these log settings are usually provided. You don't have to add them. We're going to click submit.
And hope the live demo works.
Yeah, it did. Yay!
And it is.
So we're seeing the alert. This is great. We see that this rule fired quite a few times. In Dalton, I think the powerful thing here is also we can look at the log, the Eve JSON log. If you remember earlier in the presentation, I said that the Suricata flow metadata is dumped into the syslog, which is then consumed by ntopng. Well, it's here. So if you wanted to just peek out what's going to be consumed by ntopng, you could probably do some debugging if you really wanted to. Another powerful thing is that you can kind of see some performance stats. You can also see a bit of some debug data. So suppose that we had multiple PCAPs. This is where you would use to distinguish what alert fired on what PCAP. Let's go back and do this test again, but without the alert, right? How is Dalton going to react? Well, that's great. It acts like a linter. So instead of working in a CLI, sometimes it is easier to work with a GUI like Dalton to tell you what to do next. Okay. With that in mind, I'm done sharing the demo. I'm going to go back to sharing the slides. And oops, stop presenting. I'm going to go back to the slides. Oh, cool. That's it. All right. I love Microsoft and
We
all that
practiced
it
this
can
part, and
provide.
this is the best solution.
Yeah. Okay. So presenting, we shall see which slide we end up at.
We're at the
And I'm
beginning.
gonna resume. All right. I was
Oh.
able to resume. All
There we go.
right.
Perfect.
All right. Back to you, Collin.
Okay. Let's see here. So, just a section on working as a community member, and outside in dealing with writing rules, hunting, finding anything to send over to ET over the last few years. So ET lives on feedback. They write really good rules. They do really good performance testing. But if there's problems with rules, they're never really going to know unless they get feedback on it. So if you get false positive information in your sim or in ntop or wherever you're pulling in Suricata data, it's good to send that to them and let them know. False negative data as well. If you've been dealing with an incident and you find that Suricata did not catch something it should have, that's probably even more important to send over. You don't want another customer or someone else to deal with that problem. Submitting your own signatures, just going to sites like Triage or any.run, pulling PCAPs, getting curious. Even if you just find samples that you find aren't firing inside of something like Dalton and you're not comfortable with writing a rule, that's totally something you can send the samples over and they'll write the rule. They'll give you a thanks. And if you get curious and you want to learn how they wrote it, they'll give you a ton of feedback on that. Sending any type of tips to emerging threats through their their discourse. Too many similar sounding tools. And then, just sharing samples, sharing PCAPs, anything you find. They live on this. In summary.
Yeah. Oh, well,
Sorry.
thank you, Collin, for. Oh no, no worries. I got it. The mic is on. Yeah. In summary, thank you, Collin, for giving that feedback. It's very nice that we were able to get a community member to come aboard with this presentation. And I can say that we really love interacting with Collin, and we wish more people provided some of that interaction with us too, because it gives us a lot of insight of like what people actually need in their environments. And in summary, this presentation hopefully provided you an idea of how to add more explainability in your dashboard, where to get rules, whether it be from emerging threats or from other resources to add to your dashboard, and maybe inspired some yearn to learn a little bit more about Suricata so you have a deeper understanding of what those alerts are doing. And finally, you have an idea of where to get feedback on your journey as you learn more about Suricata and how to write rules. And in terms of the last thing to say, if you have any questions, please, we're here to answer them. And if not, we'll see you on the discourse. Thank you again, everyone, for inviting us to ntop 2023.